Hello everyone. In this video, we'll see how can we create a PCB for a two-channel relay like the one you see in this picture. There are many such variants available online that you can buy yourself, but if you want to have full control over the quality of the relay board that you want to use, then it's always preferred to create your own two-channel relay board. Now, we're going to create an optocoupler based two-channel relay board so that it is completely safe to use with any and every microcontrollers that you're going to use. So let's get started. Now, in order to create this particular two-channel relay board, these are some of the components that we're going to need. Now, instead of reading you through these components, I'll just try to create a simple schematic with my own hands, and then we'll try to create a schematic and PCB for the same using EasyEDA. Let's get started. So if I have to draw a relay interfacing circuit diagram, then we all know that relay, I'm not going into the basics of it. So relay is usually having two inputs or two lines called as L1, where there is coil inside, L1 and L2. And then we have 3 points coming out. One of them is NO, one of them is common, and another one of them is NC. Now we want to create an optocoupled relay board. So what we are going to need is we are going to need an optocoupler. I'm going to use a very popular and simple optocoupler, PC817. It's a very simple optocoupler with 2 input pins and 2 output pins. There is an LED here, and then there is a phototransistor over here, which gets turned on when the LED is lit with a signal. Now, what we're going to do is we are going to need a power supply. Let's say if I'm having a 12 volt relay, then plus 12 volt here. The second point of the relay coil should go to this point, and this point should go to ground of 12 volt. Remember, we don't want to make the grounds common for 12 volt and the logic side or the microcontroller side. On the input area, all you need is a resistor, and this should go to logic 0 or ground of controller. It is different. You don't have to make it common. That's why we are using optocoupler. We also tend to use a freewheeling diode over here, like this, which helps the proper turn off of relay. And since we are creating a PCB, a two-channel relay board, we also want an indication in terms of whether the relay has turned on or not. So you can also connect a resistor and an LED like this in parallel to the relay coil. 1K resistor should be fine for a 12 volt relay. You can also use 4.7K, and that's that. Now we know this schematic, and many of you might know this schematic, but when it comes to converting it into PCB, what do we need? Now to convert it into PCB, we need a proper layout. Layout means what are going to be our interfacing pins as well. It should include what are the interfacing pins as well. Since I'm going to use two-channel relay, so I'll need a 3-pin input. So this one is for optocoupler 1, for optocoupler 2, and this can be a common ground. So let's say this goes over here like this. As we are going to use 2 relays, and it will require its own 12 volt and this ground. So what we need is we will need a connector. It should be a terminal block or larger connector where you connect the power supply. Okay, so 12 volt or whatever is the input, we'll just call it input power supply. And for the 2 relays, we are going to need 2 3-pin connectors over here, NONC common, NONC common. And then in between, you will place your 2 relays. Here you will place your 2 optocoupler ICs and all the related circuit in between. The LEDs may come here. We'll see that when we create a complete layout. So this is why we need more components, just not this. We need this connector, we need this connector, we need this connector, we need this connector as well, and the diode and the LED and the resistor and so on and so forth. So this is how we are going to create a schematic for interfacing or having a 2 relay channel PC board. Let's get started with EasyEDA and how to create this schematic. So let's have these components over here. So within an EasyEDA, go to projects. I have already created a new project, 2 channel relay board, and then there is a schematic sheet for it. Now first of all, let's take the components. Don't even bother about the quantity. We can always copy them. The very first component is 5-volt relay. Make sure you check the component and its footprint as well over here. So let me go to this 5-volt relay. This is looking good to me. Let me just maximize it. Then let's scroll a little bit more, and this is the perfect one. Okay, so I'll use this one. I'll just keep one of them. Just simply clicking R will shift the relays, and then the second one. What else we are going to need? We are going to need PC817. So the optocoupler PC817. I'm pretty sure you'll be creating a do-it-yourself PCB, so I'm choosing PTH component or through-hole components. So just select any one of them. All of them looks good. So I'll just have this PC817, one over here, one over here. Then I'm going to need 3mm LEDs. So let's just search for LED. There is also a name over here mentioned, which is LED 3mm. You can use that as well. If you want to prefer 5mm LED, it's up to you. It's just my personal preferences. I use 3mm LED. So LED 3mm, you can see number of different options are available. I choose the one which is easy to identify for cathode. So I need 2 LED, one for this relay, one for this relay. Then what we are going to need is terminal 3-pin. Let me just search it as it is. Terminal 3-pin. Okay, this is good. And then we are going to need terminal 2-pin. Let me just, you can change this. Okay, it's based on your preference, what is most suitable to you. I'll take this terminal 2-pin for power supply. Then I need resistor. LED is done. So let me just search for resistor. Again, please make sure you are checking the footprint over here. Okay, this 0805 is an SMD one. Don't use that. Simply use one which has a footprint and which shows in the footprint itself that it's a through-hole one. Just choose any one of them. Most of them should be fine. This is quite long. You don't need that. You need a quarter watt resistor. So this should be okay. However, it's again your choice. I'm just going to choose the smallest one for now. It might be too small. So resistor normal. Okay, this looks good. I need 2 over here. Then I need 2 for LEDs. Resistor are LED are done. DIN connector. We need a 2-pin DIN connector or 3-pin DIN connector over here to give the input. So let me type DIN and 3. So DIN 3. This should be good. This is to give input. DIN 3 is there. Then last thing you need is 1N4001 freewheeling diode. 1N4001. Again, you need PTH one, so choose one with a PTH footprint, printed through hole. Alright, now most of the components are here. So let's start drawing the schematic. It may get a little bit slow for you. So at this point, if you want, you can just increase the speed so that it is more comfortable to you. This terminal block is also not looking that good to me. So what I'll do is I'll change that. It's you can simply search for T block or terminal block, and you can choose one with 3-pin. This is good. This is good too. This looks better to me. So I chose this. T block 3. T block -3. That's the name. I'll choose the same for power supply as well. T block hyphen 2. A little bit. This looks good to me. Or I'll just use the same one which I have. Now, let me just clean this a little bit. Okay. So this is the optocoupler. Now, first start with the optocoupler and the input resistor. And then you have this 12 volt input signal, or whatever you may call it, 12 volt, you may call it 5 volt. It depends upon the relay configuration that you have. The simplest way, and I prefer doing it this way, is you simply have to find out a particular net port. Let me show you what a net port is. Okay. I connected one net port over here and another over here. Let me call it, you just have to give it a name, okay, plus V, and let me call it minus V. So wherever you put these names, those nets will be connected over here. So this one over here is going to be plus V, and then connect this over here. That's it. Then you need another net which is going to minus V, and this one is over here. So this goes to ground and this goes to supply voltage. All set? Now all you need to do next is, let me delete these things, or let me just also connect the terminal block. Now NC at one point, common at 1, and third one should be NO. Now let me delete all of this stuff, because all I'll do now is I'll copy and paste it. So the whole thing, copy, Control C and paste. A complete another version of it. That's it. So the output signal goes over here, from here goes to here, and from here it comes right over here. This is where the signal should be, and I didn't change it. This is very common mistake. Make sure to create these nodes correctly, otherwise it will mess up your whole circuit, and it happens with most of us. Okay, now the circuit looks good. Let's check it out. Input signal 220 ohm, optocoupler turns on. This is ground. The relay turns on. In signal goes to plus. The second one goes to collector. Emitter goes to negative. Diode in reverse configuration. LED in forward configuration. When the relay turns on, this LED will turn on. Let's make it 1K over here, or 4.7K. Depending upon if you are going to use a 12 volt supply or 24 volt supply or 5 volt supply relay. I am assuming 12 volt. So 2.2K is a safe bet. Doesn't matter. Even if you use a 24 volt relay, 2.2K should be good. Once the schematic is completely done, just save it. Now while converting this schematic to PCB, there is one important factor. If you make changes to the schematic and then you want them reflected in your PCB, then you use this button, Update PCB. For the first time only, you will use this button called Convert Schematic to PCB. So let me convert this schematic to PCB first. Units is mils, it's easier to understand. Copper layer 2, we are creating a 2-layer board. That's it, just apply it, and here is your PCB. Now, some things over here, if you try to move a component, you will see it is moving very fine. What I'm saying is, if you look at across grid, it's moving very fine. it makes it difficult many a times to align the components as we want them to be. So what you can do is simply go over here and make the snap size to be 15th mil as well as this alt to be 15. Now if you look, my component will move not that fine. It is still quite fine and it is still prone to mistakes. So what I'll do is, and normally I prefer a 30th mil grid size. So it will only move in that much distance and it is much easier to align the components when you move it this way. Now when you look at your converted PCB, the very first thing you need to do is you need to check, and I have a very big mistake over here which I'll show you. How do you check and how do you rectify that? Now if you look at it, the pin numbers are all wrong. In this relay PCB or in this footprint, this is pin number 1 and this is pin number 2. And then this is pin number 4, this is pin number 3 and this is pin number 5 as it goes here. We don't want that. Usually for a relay, this is L1, this is L2, a sugar cube relay. So this should be pin number 1, this should be pin number 2. Look at here, in 1, in 2. Then this one is common, so it should be the middle pin or pin number 3 according to our schematic. And then the NONCs are on the far two ends. So one of them is NC and one of them is NO. So the last is NO, which should be pin number 5, which is not how it is here. Now what you do in that case? There are multiple options. Simplest option is C for another component. You don't have that much time to spend and make all those changes happen. You can go to footprint, make changes here. You can go to this device and apply a different footprint, but better yet, find another component. Now let me go to library. This time I will not search for 5 volt relay. This time I'll search for KitFlix relay, which is what I have created. And let me just search for KitFlix. So you'll see KitFlix sugar cube relay. Now this is the same symbol with the same footprint, but this is according to how I need it. So let me just paste 2 of them over here. I don't want this long name over here, so I'll just convert it to RL1 and then I'll make it RL2. That should be okay. There is still a lot of names over here, so you can delete what you don't want or you can just make changes over here. I'll not go into that right now. You can do that later as well. You can also hide whatever display prefixes are here. That makes it much simpler. Now I'll delete this relay and I'll simply paste this one over here. Now just placing it, yeah, check it like that. Connections are done. So you're good to go. Same way over here, I'll delete this one and I will place this over here. Check if the connections are done. These are done, but this one thread is open. So let me just go to this point. And then over here. Similarly, check over here. Yeah, all is good. Now the changes are done. Now we need to update that over here. So let's click on this button now, update PCB. This time the new components will be shown over here. So let me pick this relay up and check the connection now. Does it look good? Yes, indeed. It is showing a cross connection which we don't want, but that is a simple fix. You just rotate this connector and this should be done. Now all you need to do is, as always, you place your components the way you want. I could have done a better job, but this is okay for now. What you can do is you just save it once the layout is completed. Now you can either auto rotate or you can manually rotate. It's up to you. You have to do a better job than what I have done in this video for sure, because this is not that good, but this is okay for understanding. If you want to use auto router, simply go to route and design and go to design rule. Set a trace width, let's say 40 should be good. Apply design rule while routing and auto placing via. Apply. And then let's try it. As you can see, the traces are well routed. Next thing you need to do is you need to manually do some work of adjustments and your PCB is ready with a lot of negative space, which you will definitely change when you do it. I know that. That's how it will look. I know it's a long video. It was a cut paste of a few more things because my desktop EasyEDA stopped working, so I had to stop in and then open it up in the browser. I usually prefer browser, but I was just using desktop one for the sake of recording. I thought it would be simpler. So I hope you will be finding it easier to experiment, to create your own boards. For sure, I'll be sharing these layouts that I create throughout these videos through the website as well. Thank you for watching.